Let's learn about the neuron's resting membrane potential. Neurons exist in an electrically imbalanced state. This occurs because of the number of positive and negative ions inside and outside of the cell. Let's take a look at the neuron cell membrane to learn more. The colored portion of this diagram represents the inside of the neuron, while the white portion represents the fluid surrounding the neuron. There are a number of negatively charged ions inside the neuron. These include organic acids such as carboxylic acid, phosphates, sulfates, proteins, RNA, and ATP. These are essentially trapped inside and work to make the inside of the cell more negative with respect to the outside. There are protein channels in the cell membrane. Potassium channels allow for potassium to move along its gradient from the inside to outside of the cell. This also works to make the inside of the cell more negative by removing positive charges. This is somewhat countered by the movement of positively charged sodium down its gradient into the cell. The membrane is more permeable to potassium than sodium, so more positive charges are lost. The sodium and potassium gradients are both maintained by the sodium-potassium pump. This active transport protein moves 3 sodium ions out of the cell and 2 potassium ions into the cell. Sodium and potassium are moved against their respective gradients by the pump using ATP for energy. The end result of all of these processes is the resting membrane potential, which is around -70 millivolts. We hope you have learned something about resting membrane potential, and see you next time.